All right, so let's talk about compound interest. Einstein said that compound interest is the most powerful force in the universe. So let's suppose you're going to take out a loan from the bank. You're going to take out a loan, a $1,000 loan, and they tell you they're going to charge you 5% interest over 3 years. And they say something about compounded quarterly. You don't know what that means, but you figure, I know math. I know how this works. I can figure this out. So we go $1,000 times 1.05 raised to the third, right? $1,000, 5%, 3 years. Hey, cool, you plug that into Desmos, and you say, all right, so over the lifetime of the loan, my total amount that I'm gonna have to pay back is $1,157.63. You're like, oh, all right, that's not too bad. And the banker says, well, no, you actually calculated that wrong. The actual amount that you're gonna have to pay when we compound this quarterly is $1,160.75. And you're like, now wait a second. I know I did this math right. What happened there? Well, the trick is compounded quarterly. See, what's happening is this 5% interest rate that they tell you, that's the yearly interest rate. But what they actually do is they split that up. They divide that 5% by 4. And then they apply that 4 times throughout the year. That's what quarterly means. So in actuality, what's happening here is you are getting 1,000 times 1 plus 0.05 over 4 raised to the power of 3 times 4. They take a quarter of the interest rate and apply it 4 times throughout the year. And that winds up costing you more money. This is what is called compound interest. And this is the one way that what you think a bank is telling you isn't actually what they're telling you. But we're not here to get political, we're here to do math, okay? And the math is that a compounding period is a common thing that you see in compound interest. They will quote you the yearly interest rate, but then compound it multiple times throughout the year, all right, by splitting that interest rate up and then applying it multiple times. All right, so let's take a look at how this works. All right, so again, we've got our principal. We've got our principal amount that we are taking a loan out, or that we are investing, or that we're putting into a savings account. All right, we've got our rate. But instead of taking the rate normally, we are going to divide that rate by however many compounding periods we have in a year. Okay, so if we're compounding it yearly, n is 1. If we're compounding it quarterly, n is 4. If we compound it monthly, n is 12. Weekly, it's 52. Daily, 365. We'll make a nice little table so we can remember what that number is. But then, we're going to compound it instead of the number of years. We're going to multiply that by the number of compounding periods. So instead of doing it one time, we're going to split it up 52 ways and do it 52 times if we were compounding weekly. Okay? So what this does is it just makes a small change to our formula. We're just adding. Let's pause. All right, announcements are over. We can get back to what we're doing. So, essentially, the equation is a slight modification of our regular exponential model formula. This is the compound interest formula. We say A is equal to that. I don't know why they use A, maybe actual, maybe, I don't know. A stands for something. But this is our principal, this is our rate, this is our time. But now we've got N. N is our compounding rate, or our compounding periods. Okay? And so if we are compounding yearly, then N is equal to 1. This is our standard case, right? R divided by 1 is just R, T times 1 is just T. Okay? If we're doing it quarterly, right, a quarter splits the year up into 4. So then we would use N equals 4. If we're doing it monthly, okay, if we're doing it monthly, then N is going to be equal to 12. And then if we're doing it weekly, then we get N equals 52. All right, and then finally, we could compound daily. Then in that case, n would be equal to 365. All right. So these are the important pieces you need to know for compound interest. But everything else calculates the exact same, right? We just find out what r over n is, change that, that's our new rate. We multiply t times n, that's our new exponent, and we solve it like normal. All right, so if t is unknown, well, then we're gonna go in and we're going to evaluate it in the exact same way that we had before. Okay, so nothing is changing except for adding this little factor of n. For your notes, you'll want to include essentially everything on this board right here. And I'll leave this up, I'm not going to erase it, so when you come into class, you'll have this here so you can copy it down. For the people at home, I recommend pausing the video and copying this down into your notes. All right, this is compound interest right here. All right? It's just a small modification to the basic exponential model formula. And that's it. Exponential growth, exponential decay, and compound interest. That's what you're going to be tested on. And that's really all you need to know as far as exponential models go. Go ahead and take a look at your bell work. Wait, no, scratch that. We're not going to have any bell work problems today. So that's it. Your video, watching this video, was your bell work. There will be a Math Excel assignment. It's already up there. It is called Exponential Models Mixed. That is due by Friday. You'll have all day class today and tomorrow to work on it.